everybody. All right, so we're going to talk about harmonics today. And so the last part of chapter 12, section 3. So let's go ahead and look and see what we have. There's a lot. So first of all, standing waves on a vibrating string. That is what a standing wave is. Fundamental frequency, which is F1 divided by V divided by lambda 1 equals V2L. And what fundamental frequency is, the frequency of vibration of a vibrating spring. So then they gave you a scenario of F1, F2, F3, and F4. And they were showing you the nodes and the anodes, as you can tell. It was telling you what the lambda 1, lambda 2, lambda 3 looked like, what the Fs looked like, and then also what type of harmonic it was. The next thing it was talking about is a harmonic series of standing waves. So to be able to do that, you have Fn, which is the frequency, times N, which is the harmonic number, and you're going to divide the speed of the wave of a spring by the 2 times the length of the vibrating spring. Standing waves in an air column, and so now it's talking about in a pipe. When we're talking about that, if open on both ends, Fn, which is frequency, is the harmonic number times speed of the pipe divided by 2 times the length of the vibration. And then it gave you these numbers here, which you're going to have to use for the math. And it was showing you for an open wind 1, 2, 3 harmonic. And then it also gave you an example of a closed pipe. First, second, and third. Showed you the diagram where the nodes and the antinodes are, and also gave you the equations that went along with it. So harmonic series of a pipe closed on one end. So then after that, it gave us this equation for this one. This is a closed pipe. This is an open pipe. Okay? So Fn, which is frequency, number of harmonics, speed of the sound pipe divided by 4 times the length of the vibration of the air column. Okay, so there's a difference here, and the difference is just the 2 or the 4. All right, so the sample problem that we have, which I felt was like super confusing, and so I'm going to go through and go and explain it to you the best that I know how. But then the sample problem or the practice problems are so much simpler. So it says when the first 3 harmonics in a 4.6 meter long brass flute is open on both ends, what is the first 3 harmonics of the pipe, which one end of the pipe is closed? Assume that the speed of sound is 3.45. So we have the length of the pipe, which is 4.6, and we also have the speed of it, which is 345 meters per second. So the first thing that they did is they tried to find F1. That seemed to be the hardest one to do, and we just used the equation that we did on these, depending on which one it is. So we took the N, V divided by 2L, which is 345, 2 times the length, which is 37.1 hertz. Then the only thing we have to do is we have to do the second and the third harmonic. And to do that, we just do 2 times this number and 3 times that number. I thought that was pretty simple. And then for an open end, we have to find out what it is for F1. And once we did, we just had to do F3 and F5 same way. So we're going to do this time N, and we're going to do, then we're going to do our N in our V and our 4L, which is 1 times 345, 4 times 4.6, which gives us 8. And then the only thing we're doing now is we're taking that, times it by 3, times it by 5, boom, boom, we're done. So let's look at problem number 1 and 2, and I only did 1 and 2, and I felt, after I did those 2, I felt pretty confident. So it says the fundamental frequency is 0.20 meters with a long organ pipe that was closed one end. Well, that tells you which one of these we're going to use, open or closed, okay? So then it tells us that the speed of sound on that pipe is 352 meters per second. So based on that, we're just going to do 1 times 3.52 divided by 4 times 0.20, and that gave us 440 hertz. Question number 2 says a flute essential of a pipe opening on both ends. The length of the flute is 66 centimeters. The first 3 harmonics of the flute are all keys are closed. Make the vibration of the the air column approximately equal to the length of the flute, and the speed of the sound is 340. So we're doing our flute 1, 2, and 3 key. So the first thing we have to do is we have to do the first key, and once we do F1, we can do F2 and F3 because we just multiply them by those numbers, okay? So we're taking 1 and we're timesing 340, and then 2 times the length, which is 66 centimeters, and I changed that to meters, okay? Because we need to have it in meters, which is 260 hertz. Once I got my 260 hertz, I multiplied by 2, got 520, multiplied 260 by 3, that gave me my 780. And then we're done for the day. I decided, when I was going through this lesson and reading all this information, that it would be best to go ahead and just leave the last unit of light and reflection for tomorrow. I hope you have a blessed day. Love you guys. Have a good day.